All right, so let's verify some identities. I've got secant of x minus cosine of x is equal to tangent of x times sine of x. So the rule is start with the most complicated side, work with that side until it matches the other side. So I'm going to start with the left-hand side, rewrite my line, okay, and then I'm going to make substitutions using trigonometric identities, which is that sheet of paper. The front side you need to have memorized or be able to prove the theorems, and then the back side I will give you. To do this problem is the stuff that you need to have memorized. So I would try these without that worksheet in front of you. If you can, do it by memory, that's the best way to go because that's what you're going to have to do on the test. This problem, I think, benefits from changing all your terms to sine and cosine first. So secant of x I can rewrite as 1 over the cosine of x. That's the reciprocal property minus the cosine of x. Okay, so again, make sure you write the property that's used. I'm given points for having the proper line and describing to me what you did on that line. Now the next thing I'm noticing is my right-hand side doesn't have any addition or subtraction in it. My left-hand side, the one I'm working on, does, which means somehow these have been combined together. How about a common denominator? So remember, this cosine of x is really over 1. So what I'm going to do is I'm going to multiply cosine of x by a unity fraction. So I have 1 over the cosine of x minus cosine of x. I'll go ahead and put that over 1, and then my unity fraction that I'm multiplying by, to make this a cosine of x, so these have a common denominator, I need to multiply the numerator and the denominator by the cosine of x. So your description there is either unity fraction, or you could say that you found a least common denominator. You don't have to say both. All right, next I'm going to multiply cosine of x times cosine of x. Y'all all know that's cosine squared of x, and the whole point of doing that is so I would have a common denominator. So that went ahead and combined together. Okay, so multiplication or multiply, simplify is also an appropriate name for that line. Now y'all know 1 minus cosine squared of x. Again, when you see a trig function squared, what I want you to think about is all of those Pythagorean identities. Now, honest to goodness, there's just one Pythagorean identity, and it says that sine squared of theta plus cosine squared of theta is equal to 1. The other 11 that we've talked about in class are all derived from that one Pythagorean identity. But 1 minus cosine squared is sine squared of the same variable. Since we're dealing with an x, 1 minus cosine squared of x is sine squared of x divided by cosine of x. So the description there, that's Pythagorean. Notice I'm running out of space. Now, this looks simplified, so I'm not thinking, how do I simplify this? Now I'm thinking, how do I get it to match the right-hand side? Well, tangent of x, we all know that's sine over cosine. And sine is just sine. Is that what we have? Well, it is. If you think about sine squared of x as sine of x times sine of x, and this cosine of x can go underneath just one of these, that's just another way to rewrite that expression. So you could say you're rewriting, or you're splitting the fraction. I use that split fraction term for really several different things. It's when you are adding and subtracting and you split it, or when you multiply, but I'm good with you using that as a description. Sine of x over cosine of x is, I'm going to go up to the right over here, is tangent of x. And then sine of x over 1 is just sine of x. And we're using the quotient property here. And then we put our little rectangle because, yay, we're finished with that identity. All right, let's verify again. I'm going to start with the left-hand side. And that's equivalent to cosine of x plus sine of x times the tangent of x. It does look more complicated than the right-hand side, so that's where I started there. Again, this one I think is screaming to turn everything into sine and cosine once again. That seems to be the most used technique, I think, when verifying identities. Cosine of x plus sine of x, they are both already the way they need to be. Tangent of x I'm going to rewrite as sine of x over cosine of x. And remember what property that is, right? That's quotient. So you're going to have to know those. All right, now I'm going to multiply this sine of x times sine of x together. When you multiply fractions, it's numerator times numerator, and there's a 1 down here, denominator times denominator. So I have cosine of x plus sine squared of x over cosine of x. And again, the explanation there is I just multiplied. All right, now notice what's going on here. I have addition of two separate fractions right here. It's got to turn into just one term, no addition or subtraction. So again, screaming at you, find a common denominator. You have to combine these together to turn two different terms into one term. So remember, this cosine of x is over 1, which means I need a cosine of x down here, which is my common denominator. I'm going to multiply by that unity fraction. So I'm going to multiply my cosine of x times the unity fraction cosine of x over cosine of x. This is equivalent to 1, which means I'm not changing the value of my equation or line here at all, because I'm multiplying this expression by the number 1, just a fancy one, and again we call it a unity fraction. Or you can tell me you're finding a common denominator, because that's how you find common denominators, is with a unity fraction. So cosine of x times cosine of x is cosine squared of x, plus this dude over here, sine squared of x, all over the common denominator, which is now cosine of x. Okay, so cosine squared, oh, by the way, what do we do? Multiply. We multiply and add, really, because I found my common denominator. I would give you credit for saying you just multiplied. Cosine squared of x plus cosine squared of x is 1. Why? Why? Pythagorean identity, right? Okay, so this is Pythagorean. All right, and then 1 over the cosine of x, aka secant of x. What identity are you using? Reciprocal. What do we do now? We put that cute rectangle and fill it in, because we are so happy we have finished another verifying the identity. Okay, verify the identity. I see a couple of ways to go with this problem. I'll try to anticipate the way that you might think to do it. I know changing everything to sine and cosine is often just the easier way to do it, but it's not often the fastest way to do a problem. But that's what I'm going to do. Okay, so you got sine squared of theta. Now, it's going to be 1 plus, remember what cotangent is, right? Cotangent is defined to be cosine in the numerator, and since it's squared, it also has to be squared over sine in the denominator, which also has to be squared because the cotangent squared. Okay, what property do we use? We use the quotient property. In other words, we use the fact that cotangent of theta is defined to be cosine of theta over sine of theta, and again, because it's squared, we squared each one. Now, what does your intuition tell you to do? Hey, mine tells me to jump right in here and multiply. So sine squared of theta times 1 is sine squared of theta, plus sine squared of theta times cosine squared of theta over sine squared of theta. Everybody sees the sine squareds cancel, correct? And that gives me cosine squared of theta. And you're using the distributive property. And you are multiplying, but that is a distributive property because you're multiplying a monomial times a binomial, so it has to go inside with each one. And then there we are, right in front of us, sine squared of theta plus cosine squared of theta is equal to 1. What do we call that? We call that the Pythagorean identity. So I say that sometimes switching to sine and cosine may take you longer. In this case, it did not. That was the way to go. We got a secant of theta minus 1 times the secant of theta plus 1, and they tell us that's tangent squared of theta. So I'm going to start again with the left-hand side, because to me it does look to be the more complicated. So secant of theta minus 1 times secant of theta plus 1. Now, what do you want to do? Well, I'm multiplying a binomial times a binomial that somehow magically turns into a monomial, one term over here. So to get there, maybe I need to expand this and see what I can do with it. I don't have any kind of substitution right now for secant of theta minus 1. There's nothing on your page that says secant of theta minus 1 is equal to something. So let's expand it. Now, the value of that is when I multiply this out, which, by the way, is the distributive property. That times that, that times that, that times that, that times that. You know the drill. But it's going to give me a square. And when I have a square, you should automatically think what? Pythagorean. So that's where we're aiming with this thing. So secant of theta times secant of theta is secant squared of theta. Secant of theta times 1 is plus secant of theta. Negative 1 times secant of theta is minus secant of theta. Then negative 1 times positive 1 is minus 1. Okay, so that is the distributive property. It's also multiplication. The secant of theta and the secant of theta negative cancel each other out, so I get secant squared of theta minus 1. All right, so like terms. And again, really we're just adding, but it's like terms that we're adding together. And then secant squared of theta minus 1 is just tangent squared of theta. So you don't know that? Aha, yes you do. That's a Pythagorean identity. That's one of those 12. And when I say there's 12, there's not. There's really just one. And the other 11 come from the fact that sin squared of theta plus cosine squared of theta equals 1. If you don't remember how to memorize them all from there, let me just show you real quick. I can do it in red on this page. So again, a study trick. But let me write down. Let me finish this thought. There we go. Pythagorean, big rectangle. That says I am finished with this problem now in red. You know the one guy. Sine squared of theta plus cosine squared of theta is equal to 1. We know that guy, right? All right, to get to the other guys, you can solve for cosine squared by subtracting the sine squared over. So then you would have cosine squared of theta is equal to 1 minus sine squared of theta. Or you can have subtract cosine over sine squared of theta is equal to 1 minus cosine squared of theta. All right, so we've got those. Now, what if I take always back to the original, I take that guy and start dividing every term by the sine squared of theta. Okay, so I'm going to do this in blue. I'm going to divide that by sine squared of theta, and divide that by sine squared of theta, and that one by sine squared of theta. Okay? So all I did was pick one of these and divide by sine squared. Pick one of these two guys, sine squared or cosine squared, and divide by sine squared. All right, that's going to give me 1 plus cotangent squared of theta is equal to 1 over sine cosecant squared of theta. And then you could write 2 more with that. Like I could solve it for 1 and have 1 equals cosecant squared of theta minus cotangent squared of theta. Or I could have cotangent squared of theta equals cosecant squared of theta minus 1. All right, so now we have 1, 2, 3, 4, 5, 6 Pythagorean identities. Now watch this. Let's go to some cute green. There we go. I'm going to go back to my original dude up here. The all-powerful sine squared of theta plus cosine squared of theta equals 1. This time, instead of dividing everything by sine squared, I'm going to divide everything by cosine squared. So cosine squared of theta here, cosine squared of theta there, and cosine squared of theta there. Now ignore the blue, okay? Sorry if you're colorblind. Sine squared of theta divided by cosine squared of theta is tangent squared of theta. Cosine squared of theta divided by cosine squared of theta is 1. And then 1 divided by cosine squared of theta is secant squared of theta. Okay? Now, I can solve for tangent squared of theta right here by subtracting the 1 over. So tangent squared of theta is equal to secant squared of theta minus 1. Or I could subtract the tangent squared over. So 1 is equal to secant squared of theta minus tangent squared of theta. That is all 12. So again, in red, 1, 2, 3. In blue, 4, 5, 6. And in green, 7, 8, 9. Okay? What am I leaving out? And I say there's 12 of them. There's not. There's only 9 of them. 1, 2, 3. Yes. Okay. So there's 9 of them. Every time I say 12, I'm adding extra stuff. That's not true. There's 9 of them. So notice what we use, though. Okay. Highlighted right here. I use secant squared of theta minus 1 is tangent squared of theta. That's this guy right here that just straight up disappeared. That highlighter didn't work here. Let me... This is a disaster. So there it is. Okay. because that's not the highlighter. That's just the yellow pen. So I erased the one that I'm using by covering it up with a yellow pen. But extra bonus over here, this shows up on the test. Again, it's going to say fill in all 9 versions of the Pythagorean identity. And that's one way to do it, with only memorizing the main guy. Sine squared of theta plus cosine squared of theta equals 1. Okay, on to the next problem. All right, so what's your plan on this one? I think my plan is to start with the left-hand side. So 1 minus the tangent of x over the sine of x. Okay. I look at my final result over here, and we're taking a single fraction that's got a minus in it already and turning it into 2 separate terms. Okay. Now, one thought is we could jump in here and change everything to sine and cosine, and you can. That would work. Before we do that, though, again, let's think about this. Because I have a monomial in the bottom, one term, I can split this fraction up. In other words, I can write this as 1 over the sine of x minus the tangent of x over the sine of x. Again, nothing wrong with changing this to sine over cosine right off the bat, and then you might have a different next step. You will get there. I promise you will get there, but this seems easier to me to follow what's going on. So that was just my first thought. We'll split this thing up. The description there would be I split my fraction. How do you know if that was the right move? Well, if you combine them back together, you better be able to get this back so you know you did it correctly. Let's see. I'm already feeling pretty good about this because 1 over sine of x is cosecant. So I've already got this guy. All right. But tangent of x over sine of x, I don't have a property for that to turn that immediately into secant, but I bet it'll work. So I'm not going to change this to cosecant just yet, even though I know it's there. I'm going to work on this guy. Now is the time, I think, to turn everything to sine and cosine. So I've got 1 over the sine of x, which in the future is cosecant, minus tangent, I'm going to write as sine of x over cosine of x, and that's still over sine of x. Notice I wrote my fraction bar a little longer there. The original fraction bar I wrote longer, and there's my tangent. So what property did I use? Quotient. Okay. Now, this is called a complex fraction for good reason, right? You got a fraction inside of another fraction. That cannot stay. We're going to have to do something about that. So that's 1 over the sine of x. The rule is when you divide by a fraction, you flip or you invert and multiply. Another way to say that is you're multiplying by the reciprocal of your denominator. So when I flip sine of x upside down, it's 1 over the sine of x. And again, you're just dividing or multiplying. Probably better to say you're dividing fractions. Yes, that is what that says, dividing fractions. I know you see it clearly. All right. Now, the sine of x and the sine of x cancel each other out. So now I'm left with 1 over the sine of x minus 1 over the cosine of x. Okay. What would I say for my explanation there? I cancel common factors, sine and cosine. Now, I don't write it right on top of my line because this line, what's happening here is what my description is over here. So from here to here, I canceled. Now, 1 over sine of x, we already know that's cosecant of x. And then 1 over cosine of x is minus secant of x. And we are finished with our proof. Don't forget to write an explanation. And we use the reciprocal property twice. All right, let's verify an identity. 1 over sine of x minus 1 plus 1 over sine of x plus 1. And they tell us that's equal to one term, negative 2 tangent of x secant of x. How do you turn 2 fractions or 2 terms into one term? You add them together. So, yep, that's the plan. I'm going to take the left-hand side and rewrite it, because that's what we're supposed to do. Makes for a good organized proof. And then I'm going to find a common denominator to add these 2 fractions together in hopes that it'll combine and simplify a great deal. Or add like terms to get rid of this plus in the middle. Now, our common denominator is simply sine of x minus 1 times sine of x plus 1. So I'm going to use some unity fraction action. I love it. Okay, so unity fraction action right here. I'm going to multiply this fraction by what's missing. So I'm going to do sine of x plus 1 over the sine of x plus 1 times what's already there, 1 over the sine of x minus 1, plus 1 over this guy, the sine of x plus 1 times the sine of x sine minus 1 over the sine of x minus 1. Just a lot of writing. So this is unity, fraction, action. Alright, so we got some unity fraction action going on over here. Now, I'm going to multiply this out. And I've told you this in class before. Rare is it that when you have, or when you find a common denominator, that you actually distribute that on the bottom. It happens. I'm not going to say it doesn't even happen in this, for this particular identity, but I don't do it until last minute. So I want to leave those factored for now. I'm going to distribute here. So that just gives me sine of x plus 1 plus this one over here, sine of x minus 1. That looks right. Okay. Now, I'm going to simplify this as much as I possibly can. So, by the way, I got to write something for this. What do? We combine like terms, and we added. So you could say you add or you combine like terms. We basically dealt with our common denominator story. So sine of x plus sine of x is 2 sine of x. Okay. We actually even haven't added like terms yet. We really just combined. We just really just added. Like terms is the next line, because now I'm doing that. 1 and negative 1 cancel. The denominator I'm leaving factored for now. That might be very temporary. Okay. Alright, so now I can put I added like terms. And I am so running out of space. This doesn't look like that. So my left hand side at this moment does not look like my right hand side. I still have addition and subtraction going on. I've somehow got to turn this into one term. We attempted by finding a common denominator, but we're just not there. So I'm going to resort to something you typically don't do, but has to happen sometimes, and this is one of those cases. I am going to distribute the denominator out, okay? So this is going to be 2 sine of x over sine of x times sine of x is sine squared of x. Sine of x times negative sine of x is minus sine of x. 1 times sine of x is plus sine of x. And 1 times negative 1 is minus 1. Okay? So distribute. That's all I did. I distributed in the denominator. Alright. Now I'm going to add like terms again. Those two guys cancel. So I'm coming up here to the right now. I'm going to change colors to avoid all this blue unity fraction action I have written over here. So I've got 2 sine of x over sine squared of x minus 1. Again, description, like terms. Alright, what's sine squared of x minus 1? That makes me go, whew. Alright, we're good, because we're going to take 2 terms and turn that into one term. What identity is that? You know it well. It's your best friend. Pythagorean identity. Okay, so I have 2 sine of x in the numerator, and I have cosine squared of x in the denominator. Now that really is that. Okay, that cosine squared means there's 2 of them, right? So watch. I've got 2 sine of x over cosine of x times cosine of x. If you can think about that, that's like 2 separate fractions. You've got 2, the 2 comes down, by the way. We're just rewriting. We're rewriting cosine squared of x. That's the best explanation I got for you there. The 2 comes down. Sine of x over cosine of x is tangent of x. And 1 over cosine of x is secant of x. Okay? What do we use? We use the quotient identity, and we use the reciprocal identity. And we finished the proof.